Welcome back to the Testing Habits podcast after a rather long spring break. So in this episode, I'm talking with a bunch of people from different organizations. So this is a very interesting discussion with Raluca Marinescu, traction control engineer at Alstom, and Daran Smalley, brakes subsystems manager at the same company. They are joined by Muhammad Abbas and Sarmad Bashir, researchers and PhD students at RISE and Mälardalen University, and Sean Malm, teacher and PhD student at the same university, all working in close collaboration in several research projects. So we cover some ground related to model-based system engineering, test automation, testing, Simulink, requirements engineering, code quality. And now I bring you Raluca Marinescu, Daran Smalley, Muhammad Abbas, Sarmad Bashir, and Sean Malm. Enjoy. Yeah, thank you everyone for coming. It's a pleasure to have you all here. I was thinking to start with a very simple question, mainly addressed to Alstom and to Raluca and Daran. So why did you join SmartDelta?
Yeah, we talked about this one before, and I was there from the beginning, so I guess I can answer that one. When we were in shift beforehand, we saw some of the good work coming from this and a lot of potential for different tools and different ways of working. From the team in here, when we had Abbas come over and show the potential of using the Vara tool, that was looking really promising. So we saw that the SmartDelta had possibilities of continuing this development. So we could also keep focusing on improving our software development and requirement handling. And since we worked, I believe, quite well together in Shift, it was a great opportunity to continue that work into SmartDelta. SmartDelta also, yes, we do handle a lot of variance. So once we developed our new way of working with our new products, then the SmartDelta was a way to try and understand the best practices and improvement on how we should do product handling. As we're slowly rolling out this product to almost around 10 projects now, you start seeing some issues popping up and getting quite a bit of lessons learned about the good side and the bad side about how we're handling product development and rolling out to projects. So hence SmartDelta is supporting us with that. So that's why we jumped into SmartDelta.
Seems like a good reason. So maybe I can ask a follow-up. So you're, developing products in the railway domain. I guess there are different systems you're developing inside Alstom that will go on the train. How are you working with development engineering? You have different practices, I guess. Anything that anything interesting that you want to share on how you're working developing software and systems?
That's a huge question. So
I know.
I think I'll give one and I'll pass off to Raluca as well. So I think since you mentioned the rail domain, and therefore from our perspective, as we develop products, we're developing it to conform to standards and norms and safety levels so we can ensure that it works as intended on the train. And what is different is there's different interpretations of that standard, and how you interpret that standard will determine how you create an efficient software development workflow. So as people interpret it differently, you actually start seeing different software development workflows, which is really interesting. That there's still a lot of human involvement, and human is not 100% precise, and there still is some leniency even with standards. That's what I'm finding really interesting from the software development in the rail industry. Raluca, what about yourself?
I don't know, Eddie, can you repeat the question?
Yeah, I'm interested in what kind of engineering practices you use. For example, it could be that agile or model-based system engineering or product line engineering. I'm more interested in those techniques and how you are working with them.
So reflecting a bit on this, I would have to come back to what Daran said. Take Agile, for example. So of course we want to work Agile, but we work with a standard that has a V model in it. So we are working as agile as we can, but we still have a standard to follow. We still have a process with gates and checks at a specific gate that we have to obey by. But what is not really demanded by the standard, then it's where we can improve, we can optimize, we can look at state of the art, state of the practice, and things like that. But we still have a standard in the background, and we still have to abide by that standard. So, yeah.
Yeah. So just as a follow up, maybe I can ask Daran. Is like, because I guess you're using, you said you have, of course, you produce products that are quite different, and they are, I guess, variants of each other. You're doing some type of product line engineering. So how do you handle, variability?
There's a lot of legacy ways of working that came in here, and you've got the existing projects that are executed, and you have a team of different architects that communicate with each other about what is happening inside the projects, and that information is then coming back to feed into what the product should work like. So it is a lot of people interaction, and it's not such a formal way of working. So the power of Fika is still quite powerful here. But once you go from a product to a project, you're doing a clone and own principle. So you clone the product and put it in the project. And then the full focus of the project is to execute that project just enough to meet the standards, the safety norms, and the customer needs. So the product is trying to think of a bigger market, and the projects are just doing just enough and driving hard to complete that objective. So the way of handling the product is, yes, a lot of interaction with different software developers and software architects.
Very interesting. Yeah, and this, I guess, goes hand in hand with system engineering, and I assume you're using different tools for developing your software and your system. What kind of tools you're using for managing the complexity, system complexity, and developing software, generating maybe code?
Software complexity. That was an interesting one. The complexity side, this is when we started looking at variance. There was a tool that came up, pure variance as well, and that was looked at from the organization. Magic Draw also looked at the organization, and now System Composer as well, with Simulink in the background. So when we first moved to the model-based system engineering approach, we started to use a lot of modeling. We then tried to incorporate within those models the variant handling mechanisms. So you can handle those variants based upon what you hear from the projects and experience from our senior experts. So they've built up a product with the knowledge they have of different variants, as long with information from projects. And then on the top level inside your product is you have a variant handling, which says, okay, which variants are we using based upon the system that we're controlling. So when we're looking at that complexity, we're only ever looking based upon the knowledge of the senior experts, and then creating a variant handling matrix to say which options are we including or not.
Yeah, I mean, I was including also maybe tools like Simulink, I guess, in this category, like because it helps you manage also system complexity to some extent compared to other tools.
I'll pass off to Raluca then. If
you're
thinking of what's the tools today, then. Sure.
So when it comes to tools, I think we use the classic. We will use doors for requirements, and then we use Simulink for modeling, code generation, some tests as well we can do in Simulink, and so on. And of course, trying to keep up with the Simulink developments, like trying to incorporate System Composer, which is a bit of a newer toolbox, is also within our focus a bit. Yeah.
And the variant handling, did what I described make sense, or is it a bit?
I think it's interesting. It's an interesting question. I think if you look at, let's say, traction control, we are a system that has a lot of variance. So we need to produce code that is for AC system, DC system, motion cooled, force cooled. You have a lot of variance within our system. So how we work, how we define our variance and how we work with variance is always a bit of a question. I think Simulink has provided, from a tooling perspective, Simulink has provided good enough support for us to be able to model and to generate code from models that have this variance in them. So I think what I can say is that we are at the stage where probably our models can keep up with the complexity of the systems that we are trying to design. And then we generate code from those models. That's a plus.
When you're talking about systems, so we see a very strong correlation between our variance and the hardware.
Yes.
So as the hardware changes, our software has to adapt.
Yes.
So we're very dependent upon the hardware configuration.
Yes. And that's like the first variation. And then you have, of course, very specific requirements that come from a project, but that's further down the line as well.
Yeah, I mean, this is very interesting. And I think the complexity of developing such systems is, affecting how efficient and how effective you are, I mean, during development. Maybe I can now go to the other side of the use case from Alstom. I know that there are some cool tools developed by people at Mälardalen University, Rise. I guess it's EFAC. There are other companies in the project and universities that are developing tools for improving some parts of your development process. So I'm wondering. Let's start from maybe the requirements engineering side. Maybe we have something to say, Sarmad, about the tools that can be helpful to Alstom, and how are these tools applied?
Yeah, so basically we are looking at automating different parts of the requirements engineering process at Alstom. So given a particular use case where this requirements engineering process, as other companies, starts from, let's say, from the project acquisition. So initially it starts with the tender documents. So in these tender documents at Alstom, they get these documents as textual ones, and it may contain a lot of potential requirements. And these potential requirements are being identified by the vehicle team and internalized by them manually. So what we are trying to do at Rise is automate this process by using large language models, which are nowadays very buzz within the computer science domain, given the release of Chat GPT as well. So they, at the back end, we are using basically language models that can help us identify the potential requirements in these large tender documents. So instead of going through the process manually, we can just pass, let's say, a PDF file to the pipeline, and then we extract the text from it, pass it to the language model, and then identify like these chunk of text are either requirements, potential requirements, or just the supporting information, and give the output again a PDF file with highlighted potential requirements. So it can facilitate the process, fasten up the pipeline in order to identify it, and then they can focus on other parts of the requirements engineering process. That is basically, once these requirements are identified and agreed upon, they can be allocated to different teams for development. So this is one part on which we are working on.
Kind of
Very
a
cool.
follow-up to this is, have you seen many variants between different requirements? So they have the same functional desire, but they're written in different ways, mainly because they'll be written by different authors, different from outside customers. Are you also seeing a lot of variance there? And how you think you're managing those variants in the grammar and the text and the words used?
Yeah, Abbas, do you want to take this one, or should I?
Yeah, you can talk about. Yeah, well, we initially, Sarmad, you can talk about how we remove duplicates maybe from the tender
Yeah,
document.
so yes, there are a lot of, let's say, similarities or different in these different requirements. We can say like as they are allocated to, let's say, different teams, so they have different variations in it. So firstly, we do a lot of pre-processing before fine-tuning these large language models, because we see that, let's say, uh, a chunk of text is similar to the other one, and like they have a similarity of, let's say, 90%. But if we train the model will be confused, and it could be identified as requirement, but it could be allocated to same team, although they were should be allocated to like different teams. So based on that, we skim those requirements, we detect those similarities, and then assign them, mainly improve them, and consider them as a single requirement in order to train those models. So there is a lot of pre-processing involved in it, and also the post-processing as well. So one part was the identification of requirements. Here we are just pre-processing it, and then the goal is to just identify the requirements. Once requirements are identified, we then automatically allocate them to different teams. Here, the other part involves of looking at these similarities or variabilities between these requirements. So they could be allocated to their own teams with higher accuracy. And here we basically apply different post processing steps. So
Yeah, and maybe I can add if that's okay, Eddie.
Of course.
Yeah, so well, with regards to the variance, is Sarma's research is mainly on identifying the requirements within the tender documents and then looking for a particular team which can implement those requirements. So the variance in itself doesn't matter that much if we have, like, let's assume 90% similarity with another requirement, which is based on, let's say, which is making the trend 2 motors or 4 motors or so on. So this variance doesn't matter, since it will be assigned to the same team anyway, because that same team is responsible for their specific part of the trend. It starts to play a little bit bigger role in the sense if you are trying to find reusable components in the later phases, which we are also developing, like the tool chain, which starts from these standard documents, then we allocate them to teams, and then we try to find reusable assets in form of Simulink models to be reused. And there it could be a little bit of a problem. And the way to deal with it is, currently we are extending these approaches to compare these requirements, but also look into the actual configuration parameters of these Simulink models and see how does this small 10% of difference between the requirements affect the actual configuration parameters in these models. We have thought about it and not looked into it yet. So we are trying to also look into that.
Very interesting. I mean, I guess there are other tools that are used at the requirements level. Maybe you can say a couple of words, Abbas, I guess, since you already started talking about Vara and about reuse analysis. How is this done in this on the Alstom use case?
Yeah, so within the scope of SmartDelta, so Vara is coming actually from the Shift project as a prototype tool, but now what Vara means is it's a tool chain. So it starts with uploading PDFs from tender documents to support the vehicle teams in identifying requirements from these tender documents. And this the aim with this whole tool chain is to we are calling it Vara Plus, which also incorporates research of Sarmad and us at Rise, other people too, and also your tool there, something which I think one of your student and you did. So what we are doing there, we had a small demo with Daran too. So this tool basically is a tool chain which first identifies requirement in the tender documents. And before actually assigning them to teams for implementation, we do some quality checks based on a tool by Mälardalen University, which is open source. So we took the code and ported it into our pipeline with a little bit of improvements. And there, what we are after is identifying requirements which are more complex or that could be interpreted subjectively, or that they are not readable, and so on. So we compute a certain number of metrics on them, and particularly the important ones are readability index and complexity and subjectivity. And with these metrics, we also highlight the exact parts on where the requirements should be improved. And after the requirements are improved, they could be assigned to different teams for implementation. Once the requirements are there, we actually go into the Simulink models and look into where were the existing requirements linked to which Simulink model. And based on that, what we do is we have a recommender system called Vara, and that particular part of the tool is responsible for generating reuse recommendations based on requirement similarity.
Yeah. I mean, I know about this tool, and I think it's cool that it's applied on the Alstom case. And maybe I can come back. We can come back to this later. I want to just hear from Raluca or Daran. You can decide who wants to answer. I know that you're going back to the software. So now, after the requirements are written, you reused, then you have to develop and test the software. How I know that you're using Simulink, and how can Simulink be used for test automation and continuous integration?
I'll pass off to Raluca if that's want to be the first.
Okay. So test automation, that's a difficult one, because I mean, when you say test automation, the first thing that comes to my mind is automatic test generation. And Simulink has a toolbox for that. It's called Simulink Design Verifier, where you can basically generate tests for a specific model.
That was based on code coverage.
Yes, in an attempt to reach 100% code coverage. So this is purely to cover code. It's not based, it doesn't take requirements or anything as an input. So we have looked at that, and we have decided that the readability of those test cases was not very good for what we were aiming, for the test that we were aiming. So then we decided that manually written tests, even in Simulink, are the best option for us. So basically what we do now when it comes to testing, we look at our requirements, we look at our specification, and then we write test specification based on those, and then we run the tests in Simulink. So we have a big test suite for all of our components, where you have all the tests there.
To clarify, so the test specification is written in Simulink, so it's an executable test specification.
Yes,
I think the other one is with the paper when we had a student work for us, Anton, who looked at design verifier and looked at these automatic test case generation.
Yes.
And the conclusion from the paper and what we believed here in Alstom as well is that there's another tool inside it called Bug Finder. And that's now looking at your mathematical model and trying to find dead code. And we found that more valuable than automatic test case generation based on code coverage.
So Simulink Design Verifier, I mean, just to has a model checker behind it, and it uses a model checker to generate the test cases, and it has certain properties. It can check certain properties with this. You can check division by zero, dead code. There's some few others there. So yes, while we didn't think that the code generation was for us, there are some interesting features there. And I think this is something that it will also might be extended over time. So as new releases of MathWorks will come in the future years, it can be even more interesting to keep an eye out on what they're doing with this toolbox.
I think we also used the conclusion. So there's when Anton was here doing the work, he found these issues using those tools. And then that resulted in a few of our models actually being updated based on that feedback. So our senior expert wasn't aware of it. So this helped highlight to him that, oh, there is something that needs to be changed. And that was on about 2% of our models.
Yeah.
And resulted in update. So it did support us. Are you continuing with your verification?
Yeah, so basically what we do is that once a software component is being tested, if we consider that the result matches the specification, the test result is according to the test specification, then we capture a run on those test cases, and then we save them later on. And every time we do a baseline, we run our tests again and we compare with these baseline results. And then this is another way to basically use Simulink when it comes to testing our software components.
Did you want to go into the test assessments as well? Example assessments?
It depends on you.
So
if you want to go into that.
So Simulink has a way to automatically write your checks. So basically, you feed it your input and you can define mathematical syntax for what is your expected output. That can use temporal logic or basic, a basic structure to write what's your expected output. We use that a lot for our simplified models. Some of our components are quite complex, and it becomes extremely difficult to write what you expect on the output if you want to use this type of checks. So because of that, we decided that it's just easier to just look at the specification and say, okay, this is what I'm expecting on the output, and then visually inspect the signals and say, is this correct? Yes. Is this correct? Yes. Is this correct? And the test passes.
Yeah.
Again, it's something that we found that works for us. And I think this is also because people who were using our previous systems, they didn't had any options to write automatic checks. So people are used to looking at the output signals and evaluate if the system is implemented correctly or not.
Yeah, very good. Very good description of what you mean, what you do in the test automation field, which I really appreciate, because in industry, most of the people that when you tell them about test automation, they will assume that is the automation of the execution of the test cases. but in when you explain it, it included not only the test automation framework in the execution of test cases, but also the test case design, the test generation part, which could be useful to some extent. I appreciate that. I think it's interesting. But I will go now to Sean, because I think he he can tell us more about what he's working with in the ABB use case. And I think what I would ask him is, we know that now, okay, so they produce a lot of code and test code. Can you maybe give me more details on how, static analysis and automatic code review can improve the way Alstom develops software and testware?
Yeah, let's give it a try. I just want to, no need to correct ABB to Alstom. I guess everyone knows.
Yeah, we started ABB.
But yeah, so my general research is looking into the automation of the quality assurance process. So you have Abbas and Sarmad who are dealing with the requirements and these kind of things, and then that gets then implemented, and then something needs to be checked that this is actually implemented in a correct way according to the different safety standards, but also the internal standards that are at Alstom. So it's already been mentioned a bit that the work is mostly done. The development work is mostly done in this MATLAB Simulink, and so Simulink already provides quite a decent toolbox of static checks on models on the model level. And then you also mentioned this bug finder, which is the policy-based bug finder, which will then you do static analysis on the C and C++ code. So what I'm trying to do is mostly to enable these sort of checks to be done earlier in the process, because one of the downsides with using sort of what I would say called traditional static analysis tools is that they require C code, for example, and then the code needs to be generated, which is a non-trivial process in terms of time. And if you're a developer and you want to check something, you may not want to wait for this information to go through the pipeline of first of all being generated and then being fed through a potentially expensive static analysis process. So what we are looking at is how we can sort of shift these. First of all, what sort of analysis are currently being done on the code level that can potentially be shifted to the model level, but also if there are things that are not done automatically at the moment, then how can we enable the automation of certain quality requirements when it comes to the model-based development requirements that are agreed upon by the company.
Very interesting. Yeah, sorry, go ahead.
Yeah, I was on a follow-up for Sean, and I know that we looked at one of them, which was how we handle signal naming convention and so forth. And you had some really cool initiatives of, like, when you go Googling something, you write some letters and it gives you a proposal. A similar concept was then raised, which was if we start proposing what the designers think they want to have, then you actually start getting something that's more consistent. I'm wondering, have you had any feedback on that tool? And are you noticing any consistency improvements as engineers are given suggestions?
Not as of yet. There were engineers that were positive about the tool, but it is available to them. But I need to do a bit of work, because there are currently things in the backend that might not be suitable for. And there are, I should say that the tool as written is quite tied to the official guideline documents. Then I noticed when I started looking into the models that there are deviations from the standard naming for specific reasons, and I've heard discussions that this is something that potentially should be left onto the developer itself, that there should be some way to locally say that, okay, I know that these are the requirements, but I will deviate because of clarity or because of reasons, and then this is something that you can specify in the for example, in this kind of doc block or some documentation for the model itself. And then this is something that I would like to be able to provide, but then I need to figure out how this can be essentially specified so that the tool can sort of ignore these kind of violations. And then there are a number of special cases. So the tool is looking at probably the vast majority of signals should be okay, but then there are specific cases that need to be handled with a bit more care.
Very interesting. I'm wondering now, maybe I can ask a more controversial question now and see where we get. There is this move towards more, automation and use of machine learning or artificial intelligence during development of safety critical software. So there are different tools that one can use to improve the way you develop software. And I wonder how much you think about the challenges of using such system and the over-reliance on the results of automation. You trust the results, but you don't really check if that's the case or if there was a mistake. I wonder, how do you take that into account, and not only now but also for the future, when we rely more and more on tools that provide us results based on historical information. And I don't know who wants to take this on.
You can give it a shot. There's multiple things to your question, and I'll try and give enough time to everyone, so I'll try and be concise. There's something we've been looking into, is the concept of reusable code. It's allowed inside the standard. And the concept there was, I don't really know what was the verification performed on a particular chunk of code, because I may have got it online or from somewhere. But I can use that code. I can read the data sheet on the code saying how to integrate it. I will integrate that code into my system, and then I'm going to treat it like a black box. So I'm going to perform all the different tests to ensure that this code is going to work as intended in all the different scenarios that is specified on the software development. So when we consider AI generated code in that context, we can also consider that in the same way, which is it becomes a black box, but then the responsibility for verification becomes more onerous, that you have to ensure that that black box will behave as intended. So with AI creating small library blocks, or they're creating small components that are not very complex, that's fine, because there's not too many test cases that you have to perform to ensure it behaves as intended. As that black box gets bigger and bigger, then we have to handle a lot more verification scenarios. So therefore, it's a lot more onerous on the verification aspect. So as of today, that means that we would have a shift from the effort being on design to the effort being on verification. So that's one aspect. The second one, you said reliance on tools and infrastructure. We have seen in the past that when we run a certain way and the computer says, yes, this is okay, that you start trusting it more and more, the more reliable that is. So the false positives and false negatives and all the issues you're going to see on programs that you trust, you're less likely to find them. And to ensure that this isn't a significant problem on the train, you still have the essential tests that you always run, that then you have to have that person or an expert to look at them. So it is a problem. We have noticed the problem, and we kind of have different stages of testing, and to ensure that you always check all the safety features are working as intended. So the worst case situation is you end up in a safe state, and those
safety
are
first.
critical. Yes, exactly, no exception. However, that's how I've witnessed this trend towards the AI. So more on the verification than design.
Any other opinions or
anyone else?
Well, I would just add, just a small thing. We are bound on the standards that we have to follow. So within that standard, yes, a bit of flexibility here and there, but at the end of the day, we have to deliver a software that is developed according to the standard that we work with. So yes, that's that doesn't leave us with a lot of room.
Yeah, that's a good point. Yeah. Abbas, you wanted to say something?
Yes, so I was just saying that it's also interesting to look at, because the AI that we are doing in the different projects is not part of the system, that they have to show compliance with different safety standard. I mean, it's a problem if AI is part of the system and the system has to get a certification. But probably it's not a big problem if the process is supported by AI. For instance, the process of recommending reuse is something that they don't have to, that doesn't have to go through the safety compliance. So this is one thing. And another interpretation, when I see the train industry, it's quite old. I think they have to move because AI is now everywhere, automation is everywhere, and probably they need more updated standards, particularly for these cases. And before that, I was also working with some aviation industry in Pakistan, and we also noticed that they cannot even use basic object-oriented concepts such as polymorphism, because the DO178C standard dictates to use like decades-old C, for instance. So they can
but maybe that's for maybe that's for the better,
or for the worse.
No, I think it's maybe better not to use those concepts on avionics software.
I mean, I have comments on the safety issues of object-oriented programming concept, but that might be a different conversation.
No, I think I can hear a couple of, if you have a couple of words about that, I would be happy to hear them.
I mean, it will cause, from what I understand, a huge issue if you want to do any sort of certification, because it's vastly more difficult to analyze and to prove that these kind of systems will hold certain properties, because you cannot rely on the code alone. You need some sort of information about the runtime when you have this kind of, I mean, polymorphism, because then you have virtual functions, which means that a function call can actually go to a place that you're not sure of. So I mean, it makes the processes that we have to do certification, I think quite a bit more expensive. And if that is something that would then require us to start using AI, then that will be an arms race, I think.
Yeah. I totally agree, and maybe I can just say that I think the question came also from the fact that I think the use of AI during development of systems. So this is something that, for example, we have a lot of research efforts that are providing improvements in specification, analysis, testing. Then you have a lot of tools and techniques for the development and analysis of the system. And what, for me, from my perspective, is largely missing in current research efforts, it's the discussion of how we will be able to trust our powerful automated techniques enough to allow us to use them as a replacement for something that we do traditionally. And I'm saying that, of course, also with the notion that I know how much improvement this can be gained by using these techniques. But if the code generation is incorrect, for example, the resulting implementation will naturally be incorrect. And it might not be code, since we're not reducing testing in the code domain. We are now reducing testing in the code domain, I guess. But if, for example, if the analysis tools applied to the models provide false negatives, they fail to catch a faulty model, and then we might generate code that is incorrect. So that's my fear comes from the fact that, yeah, we need to understand better this. But I really like your perspectives. I think it's good to have different perspective on this.
I think it might be good to note that I guess there's two aspects. One is the human in the loop versus human outside the loop. So as you talked about, they're suggestion based, which means the tools, no matter how they're created, are only providing suggestions, and that is it. So that is supporting the workflow by providing suggestions to the designer or verifier. You have the next one, which is it is a trusted tool. So I just need to look at the output, and I can trust it's done everything else correctly. And there's different rankings for those type of tools as well, which is your T1, T2, T3 tools. And depends on what part of the process are affecting. There's different levels of scrutiny on those tools. So what we're finding is things that are moving quickly, like the AI domain and so forth, we try and keep the human in the loop. But that means there's more ownership on the tool developers, that when the tool is created and provides suggestions, it needs to be created in a way that a human can read it. And then you have to go from that machine world to a human interface. And that is not always easy to do. It's not a trivial task to be able to explain to the engineer or whoever's reviewing the advice why he came up with that suggestion.
That's a good point. Of course, there is always this problem, even if the tool is suggesting something, if the human, it's in our human nature to get those suggestions and think, well, they might be true just because a tool generated those. So there is this over-reliance even in suggestions, especially for people that I guess they're in the beginning. I think it's an interesting problem. Sorry, I didn't know. Abbas, yes, you wanted to say something.
Yeah, so one thing that we did in this regard was also to generate explanations, especially in the work where we are allocating requirements to different teams. And the idea being that deep neural networks or large language models are not explainable by itself. So it makes decisions by crunching some numbers, and humans might not know. But well, there is traditional AI, which makes decisions on very lexical features, for instance, or rule-based approaches. And the idea there is that you could combine the two and try to generate explanations. In those cases, what we did is retrieved 5 most similar requirements and see how much of those were allocated to which teams for implementation, for example. And that is the help that the extra help that we provide to the requirements engineer for allocating requirements to different teams. So we do a prediction based on some number crunching that we cannot explain, but then we use traditional AI to say, okay, here is the 5 most similar requirements that were allocated to this team, which can help bring up new information and help support the decision of allocation in that particular case.
Thanks, Abbas. Yeah, I think this is a really good example of how to improve such tools so that they are you can trust the results more and the explanations make more sense. I think this is a very good point. So maybe we're getting maybe towards the end, but I wanted maybe to ask an overall question is, since Alstom in SmartDelta is interested in, trying to incorporate, for example, product line updates into existing application, maybe the efficient evolution of software artifacts, or test automation. There are different aspects here, how to improve model-based system engineering, I guess. I'm wondering how do you expect SmartDelta could help with this? And this is maybe mainly a question to Daran and Raluca.
It sounds like a question that you ask at the start.
Yeah.
I was going to say, no, it's easy because you just heard what we have from Sarmad, Sean, and Abbas. So what they're working on, that's what we would like to use. When you're in general with the product line engineering, again, we have the requirements, we have the customer projects, we see variance there, and we have a lot of work there from Sarmad and Abbas, and really keen during this project to take what they have, test it out on a few different projects. And then as we progress through the development is to use Sean's advice on updates to improve our automation of these checks and see if we can gain more consistency in our products. As we increase the consistency in our products and make sure we're following a standard, it means we can easily move between product line and project work because you see more consistency in both environments. So people don't have to keep rereading the same code and see the variance between projects and products as much.
Yeah, I mean, sorry, go ahead.
Oh, please.
No, I was like, it's a good point. That, I mean, this is a question that you would ask in the beginning, but I'm asking it at the end because now you heard quite a lot. And I'm curious what do you expect SmartDelta could help, in the future, and what needs to be improved and what's the next step. But I think it's a very good answer. Sorry, Raluca.
No, it's something else I guess I would like to add to that is we Raluca and myself are coming back from the mindset of traction. And so we're talking about consistency and all the improvements, but we're also working within other departments. So we've got our train control monitoring system as well and supporting them. So the more consistency we have between the two departments means it's more easy for teams to work together and to share information between each other and share code between each other. And as I mentioned at the very beginning of the podcast, I've gone to breaks and we're starting from a blank piece of paper. It's not really true. It's not really blank. We're trying to take what we can from traction and try and reuse as much as we can and using what we've had from SmartDelta. So SmartDelta is not just affecting one side of Alstom, it's affecting a few different departments.
Did I look at? I don't know if you wanted to say something, but
I think what I find interesting about SmartDelta is that we have had several PhD students and coming and sitting with us. And I think that has a huge impact because if you look at people who work at Traction, for example, we really focus on developing our products and making our deadlines. That's our focus. And yes, we have a really good state of the practice. We use a lot of tools that help us with code generation and developing our systems as fast as possible, reuse as much as possible, and so on. But at the end of the day, we're focused on developing our products and meeting our deadlines. Now, when you have people from academia then come and sit with us, you know your state of the art, and then you can see exactly where you can help. And I think that's also really good, because if you have spent a bit of time with us, looked at our way of working and the problems that you have, you can come and you can suggest things that perhaps we didn't consider before. And you also have a bit of time and flexibility to do a proof of concept on these things. So then when we see them in practice, they become more relevant for us and easier to adopt than if you say, hey, can you please read this paper? So yeah, I think it is a really nice setup in SmartDelta.
Yeah, this is I think this is a very good way to end this podcast. I think it was very, very, very nice to hear you all, and I appreciate you doing this.
Thank you for giving us your time. It's been a pleasure.
Yes, thank you.
Yeah, thank you so much.